Happy St. Patrick's Day, everyone. I hope that you're all enjoying it. It's supposed to be 55 today, and I hope you all get outside and enjoy it at some point. Hope you're wearing green. I'm representing Ireland. If you're celebrating by wearing something festive and you'd like to send me a picture. I'd like to see your festivity or your festiveness. All right, let's get into the math. Get me out of the way. All right, so today's lesson 24. We're going to do the problem set together, as always, on Wednesdays. And then you are on your own for your exit ticket. Now, remember, I sent home exit ticket copies yesterday, but if you don't have that or can't find it or didn't grab it, just do it on a piece of paper. You don't have to write the question down. You just have to do the work and then make sure you submit that. Today, we're doing word problems, and we're solving those by using our knowledge of fractions and decimals and how we multiply them. So let's get right into it. Come on, get up. Oh, my toolbar's in the way. Come on. There we go. All right. So let's get our name on our problem set. If you have the book still, if not, practice this on just a regular piece of paper. All right. So a vial contains 20 milliliters of medicine. If each dose is 1/8 of the vial, how many milliliters is each dose? Express your answer as a decimal. So we always want to follow the read, draw, write. So let's just make a tape diagram to kind of make sense of it. This is our one whole vial, and we're looking for 20 milliliters. And we want to find 1/8 of, we want to find the dosage, right? So we need to find 1/8 of it. So 2, 3, 4, 5, 6, 7, 8. So we're looking for this 1/8 piece. Well, how do we solve for that? Well, 1/8 of 20 milliliters. So we're going to be looking for 1/8 times 20. Now, knowing what we know about multiplying fractions, if we're starting with 20 and we're multiplying by 1/8, is our number going to be bigger or smaller than what we started with? Well, we're multiplying, our scaling factor is 1/8, so that means it's less than one whole. So our number should be less than 20, which makes sense if we think about our tape diagram. We couldn't have more than 20 in one of those parts if the whole is 20. So let's go ahead and solve through this. Well, we know that 1/8 times 20 looks like that, and we have to make sure that top times top, which is numerator times numerator, so 20 times 1 is 20. And then denominator times denominator, or bottom times bottom, 8 times 1 is 8. Now, 28 is the right answer, but there's a better way to represent it, a better way to make it make sense. And that's by converting it into a mixed number. So if we think about how many 8/8, how many wholes we can pull out of 20, 8/8, 16/8, third group would be 24/8. So I can't do that. So I can do 16/8, which we know is, oops, let me put the equal sign in a better spot, which equals 2. And then that would leave us with 4/8. So we could leave the answer as 2 and 4/8. But let's look back at the unit. Well, 2 and 4/8 bananas. Well, 2 and 4/8 milliliters for each dose. Well, that doesn't even make sense. So let me put a few words extra in it. There is 2 and 4/8 milliliters for each dose of medicine. Kind of interesting that that's our question for today, connecting it to the COVID vaccines. I don't know how much my COVID vaccine dosage was. It wasn't much, but all right. Some people would simplify 2 and 4/8 as, yeah, 2.5. Good job. All right. Let's go on to number 2. A container holds 0.7 or 7/10 liters of oil. You know, just to help my brain, I'm just going to write 7/10 above that. All right. A container holds 7/10 liters of oil and vinegar. 3/4 of the mixture is vinegar. How many liters of vinegar are in the container? Express your answer as both a fraction and as a decimal. So I'm going to start with fraction and then work to decimal. Okay. So let's think about what kind of drawing we'll do for this. All right. Well, the container holds 7/10. So the whole container is 7/10. And we know that we want, and 3/4 of that is, let me put 7/10 of the liter. 3/4 is what we're looking for, and that's the vinegar. We're looking for 3/4 of that is vinegar, so we don't know what that is. So how do we solve for this? Well, when we look at this tape diagram, it kind of looks very similar to this. We have a whole and we're looking for a part, and so we did the fraction times the whole. Okay, well, same thing. We have a whole and then we're looking for a part of it, so it's going to be the fraction times the whole. Now, our whole is what we start with, so that's 7/10. We're multiplying by 3/4, so that's our scaling factor. Is 7/10 going to get larger or smaller based on what we're multiplying by? Or will it stay the same? Well, 3/4 is less than 1, so our answer is going to be less than 7/10. Let me undo those marks so that we can do the work. Oh, I'm on a highlighter tool. All right, well, let's multiply top times top, numerator times numerator. So 3 times 7 is 21. 4 times 10, denominator times denominator is 40. So we got 21/40ths. Okay. Well, how do we go from here? Well, the question we have to ask ourselves is, that's the fraction, 21/40ths of a liter, but it's also asking us for a decimal. So let's think, can we make that tenths? Well, can I divide the top by 4? Because that's how I would have to make the bottom to be tenths, right? I'd divide 40 by 4. No, I can't. So remember, when we try to convert into decimals, we can make it a power of 10. So it has to be tenths, hundredths. So let's check hundredths. 40, 80, 120. No, we skip right over hundredths. Next one that we could do is tenths, hundredths, thousandths. Yeah, and we can do thousands. Let me help you with this one. We know that 4 times 25 gives us 100. So 4 tens times 20, 200. Yeah, no, by 25. Oh man, my brain wasn't working right there. Will give us thousands. Because 4 times 25 would be 100, right? And then we place that 0 behind it, and that will give us thousands. So, well, I don't know what 21 times 25 is, so I need to set that up. Standard algorithm, 5 times 1 is 5. 5 times 2 is 10. Place my 0 to go down to my tens place. 2, 4. Answer should be, I ran out of room, 525. So 525 thousandths. Now that I see it in that form, remember that thousands has 3 zeros, so that kind of gives us the hint that there's 3 digits behind the decimal. So if I just write, I'm going to just keep doing it. I hate the highlighter though. If I just write those digits back down, and then I tell myself 3 digits behind the decimal, well, there's 3 digits. Let me place the 0 in front of it. Well, 0.525 what? Well, liters, right? Now we need to place that in a statement. We now have represented it as a fraction and as a decimal. So let's go ahead and answer the question. How many liters of vinegar are in the container? So I'm going to type this. Oh, it's going to be way too big. So there is 21/40ths of a liter, or 0.525, or 525 thousandths of a liter of vinegar in the container. Really, they're making a mixture though, right? They made a mixture of vinegar and oil. All right, good job. Let's go on to page 2. Now our video is probably getting close to 10 minutes already. So let's skip, what should I say? Do you want to do one about racing, clothing factory, or Let's do this fifth grade class. It's us. All right, let's look at number 5. And then we'll go to your exit ticket. Let's draw a picture though, right? Like always, let's do a tape diagram to represent this. All right, so there are 3/4 as many boys as girls in a class of fifth graders. Oh my goodness, girls. Whew. That's actually like Mrs. Elphas's class, but opposite, right? You guys have a lot of girls in your class. If there are 35 students in the class, how many are girls? Okay, let's draw a picture. So, whoops, I don't want the typing tool. Give me my pen. All right. So we know the whole class has 35 students. And we know that 3/4 of them are boys. Oh, that just gives me a headache already, boys, and I'm a boy. All right. So let's think about what this math problem is. We have a whole and we have a fraction of the whole. I'm going to sneeze. Sorry. I'm sorry if that was loud in your ear. Bless me, by the way. So this is 3/4 of 35. Now, our whole is 35. Let's just think about what we're multiplying by. Our scaling factor is 3/4. Is our answer going to be bigger or smaller than 35? Should be smaller, right? Because we're multiplying by a fraction smaller than 1. And then again, if we look at our tape diagram, we know that all these parts are supposed to add up to 35. So if it has to be smaller than 35, right? If it was bigger, that tape diagram wouldn't make sense. All right, well, let's keep working through it. Now I'm going to put this over 1, highlighter. And let's go ahead. 3 times 35. Well, I really don't know what that is off the top of my head. So I know it's going to be something fourth. So, well, let me just set it up. It'll take 2 seconds. 3 times 5 is 15. 3 times 3 is 9. Plus 1 more is 10. So we have 105 fourths. Yeah, that's the right answer. But does that make sense? If you went up to anybody, and you said, "Hey, there's 105 fourths boys in my class," no one would understand it, right? So what we need to do is we need to divide. We need to figure out how many fourths wholes are in 105. That was really hard for me to say. But we do know that 25 groups of 4 gives us 105. So we know, or 100. So we know that it's pretty close to 25. It might. And I think if I did one more group of 4, that would be 104, and that would be 26. So this should be 26 and 1/4. Let me prove that with standard algorithm, but that's, we can work through steps in our head like that. 2 groups of 4 come out of 10, right? And so that will be 2 remaining 10s. And then I bring down my 5, and 4 groups of what? 4 groups of 6 gives us 24, and minus 1, so that would be 26 and 1/4. Wait, how is that possible? How can we have 1/4 of a student? So how do we answer this question, right? Like, can I have 1/4 of a student in this class? Oh, I think I did this problem wrong, because that's not going to make sense. Oh my goodness. Why am I drawing still? I just did that problem completely wrong with you. Oh, that's frustrating. Well, we did some good math in it, but we attacked the problem the wrong way. And that just goes to show you how easy it is to read these questions wrong. The tape diagram, let me just draw the tape diagram they wanted us to see. I'm frustrated with myself. We're going to just be done with this lesson and move on because I don't want to make it any longer for you guys. It was supposed to show that for boys and this for girls. And then we were supposed to say this was 35. So we would divide it by 7 to know that each of these sections, and that would have been our girls and this would have been our boys. Each one of these sections would be 5. That one's a tricky question. So careful on our exit ticket. Let's take a look at the exit ticket together though. My apologies, I'm making a mistake, but see how easy it is? Doesn't matter how great at math you are. It's so simple to make a mistake, but we just have to take our lumps and use them as learning moments. And that's just that growth mindset that we all try to embrace on a day in, day out. All right, so let me read it for us and let's see if we can draw our picture together. We have an artist building a sculpture out of metal and wood that weighs 14.9 kilograms. 3/4 of this weight is metal, the rest is wood. How much does the wood part of the sculpture weigh? Oh, very cool. All right, so 14.9 is our whole, and that's kilograms, so kg. Oh, that was a terrible 9, and let me get that better. Whoops. 14.9 kilograms. And that's our whole. So let me draw my picture for it. And then 3/4 of it is metal. This 3/4 is metal. And this is wood. And the wood section would be how many fourths? That's just 1/4. Okay. Well, there's two ways you can solve for it. You could solve for the metal side and then subtract it to get the wood side, or you could just do 1/4. Well, actually, let me not tell you the rest of the way. I've helped you draw the picture. Go ahead and solve the problem and take a picture and submit. Oh, actually, I think there's a second word problem. Oh my goodness, there is. I forgot about that. Being zoomed in, you don't see everything. All right, let's draw a picture for this one to help you as well. All right, on a boat tour, there are half as many children as adults, and there are 30 people on tour. How many children are there? Okay, this one's kind of like the question we just messed up on in the problem set. So we know there's half as many children. So if this is our adults, there's half as many children. But we know that all of these, there's 30. So if I think about that, if I think about cutting that in half, I'll use dotted lines because it's really not half, but how many parts are there? 1, 2, 3. Okay, 3 parts, 30 kids or 30 people. How many children are there? Good luck. Let me know if you need any help today. Good job.